A baby is watching you cook right now. Not playing, not sleeping, just completely locked onto your every move with an intensity that makes most adults feel vaguely observed. You stir a pot and those eyes follow. You open a drawer and the head turns. You taste something and the mouth opens slightly, as if expecting the same experience to transfer across the room. Most parents assume this is simple curiosity or boredom, but developmental psychologists have spent the last 2 decades studying exactly what is happening inside that tiny brain during those long, unblinking kitchen observations. And what they found doesn't just explain why babies watch you cook. It rewrites how we understand the origins of human intelligence itself. Let's start with the obvious explanation. Babies stare because movement is stimulating, and kitchens are full of it. Pots move, steam rises, colors change, sounds happen. That theory sounds reasonable until you actually look at the data. Researchers at the University of Chicago ran a controlled study in 2015, presenting infants between 8 and 16 months with two simultaneous video feeds, one showing random mechanical movement, the other showing a human performing intentional actions like cooking, folding, and building. The infants didn't just prefer the human, they tracked the human's gaze. They monitored where the person was looking before deciding where to look themselves. That is not a response to movement. That is a response to intention. And recognizing intention requires something researchers never expected to find in infants this young. Here's where it gets genuinely strange. In 2013, a team at the Max Planck Institute for Evolutionary Anthropology published findings that stopped the developmental science community cold. They presented 14-month-old infants with a simple scene, an adult performing a cooking task, then stopping before completion. The infants didn't just watch. Within moments, most of them spontaneously reached out and attempted to complete the unfinished action themselves. Not because they were taught to help, not because they were rewarded for it, but because their brains had already constructed a full model of what the adult was trying to do and felt something like compulsion when that goal went unmet. The researchers called this goal attribution. What it actually means is this: your baby watching you cook isn't passively receiving information. They are building a predictive model of your mind in real time. And that model is more sophisticated than anything we assumed was possible at this age. Researchers at Yale's Infant Cognition Center discovered that infants as young as 6 months old don't just track what adults do, they evaluate why. In their kitchen-adjacent experiment, infants watched an adult reach for an object on a high shelf repeatedly. In one condition, the object was out of reach by accident. In another, the adult could reach it but chose not to. When infants were later given the opportunity to interact with the same adult, they showed measurably different social engagement depending on which condition they had watched. They were reading motivation, not just movement. Causal understanding of human behavior, once thought to emerge around age 4 or 5, appears to begin forming in the first half of the first year of life. And it begins in places exactly like your kitchen. Now I need to tell you about a specific finding that changes everything about how you understand what the watching is actually for. Researchers at MIT's Early Childhood Cognition Lab have spent years studying what they call action segmentation, how infants break continuous human movement into meaningful units. What they found is that babies don't observe cooking the way a camera records it. They observe it the way an editor cuts a film. By 10 months old, infants show a measurable neural spike at the exact moment a human action reaches its natural completion point. The pot being placed down, the vegetable being cut, the drawer closing. Their brains are parsing your behavior into a structured sequence of goals and sub-goals, building what cognitive scientists call an event schema, a mental template for how this type of human activity works. Every time you cook in front of your baby, you are not being watched. You are being studied. And the schema being built from those observations will become part of the cognitive foundation for how they will eventually learn to do things themselves. This is where it connects to something researchers call the embodied simulation hypothesis. A team at the University of Parma discovered that certain neurons in the premotor cortex, the region responsible for planning physical movement, fire identically whether a subject performs an action or merely observes someone else performing it. These became known as mirror neurons, and their discovery in 1992 was called by some neuroscientists the most important finding in the field since the discovery of the synapse. In infants, mirror neuron activity during observation of cooking and food preparation tasks is among the highest measured during any passive observation scenario. What this means is deeply counterintuitive. When your baby watches you chop vegetables, the motor regions of their brain associated with chopping are activating. They are not watching you cook. At a neurological level, they are practicing cooking. Without hands, without ingredients, without producing a single physical result, they are running simulations, building motor programs, rehearsing futures they haven't yet lived. There is one more layer to this, and almost no one outside academic circles talks about it. Psychologists at the University of British Columbia ran a study in which infants watched two adults perform identical cooking tasks, one with positive affect, leaning in, smiling, engaged, and one with neutral or negative affect, moving mechanically without expression. Not only did infants pay more attention to the engaged adult, when given the opportunity to interact with unfamiliar objects afterward, infants who had watched the engaged adult showed significantly greater exploratory behavior, more willingness to investigate, manipulate, and experiment. The emotional tone of your cooking doesn't just affect whether your baby watches. It affects how curious they are about the world for the rest of that day. What you model at the stove teaches them not just what humans do, it teaches them what humans feel about doing things. And that distinction between mechanical imitation and motivated engagement may be one of the earliest and most important lessons a developing mind ever receives. Now, the part that has a practical edge. If you notice an infant who consistently fails to track intentional actions, who doesn't seem to differentiate between purposeful human movement and random mechanical motion, who watches your hands but never your eyes. That is not developmental immaturity to wait out. Absent or atypical action parsing in infancy is one of the earliest observable markers researchers associate with disruptions in social cognitive development. It doesn't mean something is irreversibly wrong. The brain's plasticity in the first 18 months is extraordinary, but researchers are clear. Identification before 12 months produces outcomes that identification at 24 months cannot fully replicate. If something about the way your baby watches or doesn't watch feels different, trust that instinct. You are the most finely calibrated instrument in the world for reading your own child. So the next time you're standing at the stove and you feel that small, steady gaze fixed on your back, remember what is actually happening. Your baby is not waiting to be fed. They are attending a lecture on human intentionality. They are running motor simulations in a brain with no experience to draw from. They are watching the emotional texture of what it means to do something purposeful and storing it alongside the action itself. 15,000 years of evolutionary pressure did not make infants transfixed by purposeful adult activity by accident. That attention is the mechanism by which human culture, cooking, building, making, solving, gets transmitted across generations before language ever arrives. When one of those eyes locks onto you at the counter, the only right response is to cook like it matters, because to the brain watching you, it absolutely does. If this changed how you see the small observer in your kitchen, subscribe and drop a comment below. I want to know, have you ever caught a baby watching you and felt like they understood something you didn't say? Because if you have, now you know exactly what was happening. And if you want to understand why babies laugh at nothing, at empty corners, at invisible things only they seem to see, that is the next video. The science is stranger than anything you've heard before.